Hi everyone. Today we are going to take a look at how do you set up the coding environment for Opentrons robots. So the instructions are applicable for both OT2 and Flex. Um, and the current instructions will also be suitable to set up on Windows and Mac OS, even though I'll be setting up and demonstrating this on Windows 11 virtual system right now. But yeah, you can pretty much translate these instructions directly to Mac OS. So let's take a look at what the learning objectives of this video. First, we're going to use or set this Visual Studio Code environment for Python to efficiently code Opentrons Python protocols, and then demonstrate how you can simulate the code, which means that you'll be able to debug the Python codes and find out any error, fix it, right in your VS Code application. And then also we'll be taking a look at how do you actually find out some API functions which might be disguised, or you don't have to look back into the Opentrons documentation for a quick reference. So let's take a look at what the prerequisites are. In this, we'll be using a tutorial. We'll be using Anaconda, Visual Studio Code, and the Opentrons Python documentation, and the Opentrons Python package. So let's get started with the first and foremost thing, which is the downloading Anaconda environment and Anaconda package and VS Code package. So in the browser, I'm going to type Anaconda, which will take us to this Anaconda website. And in the tab, we can download, click on free download. And you can skip the registration. It really depends on you. So there is a Miniconda available, but I suggest using Anaconda if you're new to the Conda environment. Since I'm using Python for Windows, I would like to download the 64-bit graphical installer. If you're using Mac, you can download it for Mac, Silicon, or Intel chip. And for Linux, again, you have another graphical installer, which is actually probably it's not graphical. You may have to look into the documentation for Linux. But the instructions apply across all the three platforms, which are Windows, Mac, and Linux. Meanwhile, when the Anaconda is downloading, let's go and download VS Code. So again, VS Code is available for, or Visual Studio Code is available for both or all the operating systems, which is Windows. Currently, I'm downloading it for Windows, but as you can see, it's available for Debian, RPM packages, and for Linux, and then Mac OS as well. So the first prerequisite is to install Anaconda and then install the Visual Studio. Let's take a look at the Anaconda installation. Okay, now our Anaconda is available for installation. Let's open and install it. You can run Anaconda as an administrator as well as a normal user, and we'll actually be going through each step right away. By default, Anaconda comes with Python 3.12, and for Opentrons, we require 3.10. So let's take a look at this. Let's install. So both the options are available. Right now, I'm just clicking Just Me and then install it. What we would like to do is add Anaconda to my path environment. The benefit of using Anaconda for Python is you're able to manage different Python versions. As you can see, the latest Python is 3.12, And if you're working on any other Python project, you may want to create a different environment for it. And I would strictly remain on a different environment for Opentrons because the dependencies may cause your protocol simulation to fail. And using Anaconda, you can also quickly create different environments. It's much less tedious for a new user. And also Python Anaconda package comes with pre-installed packages such as pip, which are like quick starter for you to basically get up and running. But yeah, needless to say, the original Python package also comes with pip. So we'll be creating a Python environment after the Anaconda is installed. And our requirement is to use Python 3.10 whatever version is available. Depending on your operating system, the 3.10.x version might change. So it could be 3.10.11 available for Windows, and it could be 3.10.16 available for Linux and Mac. One disadvantage of installing Anaconda package would be it is a larger package. So if you have a limited memory size and you're installing Anaconda, you might increase your space and you might run out of space. So that's the only limitation. So in terms of a roadmap, our first step is to install the Python Anaconda environment and then create an Opentrons environment in Anaconda. So let's take a look at how do we do that in Anaconda directly. Now we have Anaconda installed. We'll click on next and let's launch the Anaconda navigator. I'm not interested in the Anaconda distribution right now. Now the Anaconda navigator has launched in the background, and if you're not able to launch it immediately, you can click on Start, All Applications, Anaconda, and Anaconda Navigator. So let's go back to Anaconda. I don't have an account, so I'm just going to close this. The first thing we would like to do is create environment. And to do that, we're going to click on the environment section on the left-hand side. No update required right now. So the base is the default version where your default Python is installed via Anaconda. Now we are going to create an environment. So this environment, we are going to call it as Python, Opentrons, sorry. So let's click on create. And let's call the environment as Opentrons. Opentrons. And the Python, this is a crucial step. So we're going to use Python 3.16, so 3.10.16. We're interested in using 3.10. Whatever is available. So let's use 3.10.16. This should take a minute for it to install, create an environment, install the necessary packages. Once the installation is done, you can see the play icon over here. So now we can click on, right now the package is installed. So the first step of installing Anaconda and Opentrons Python installation is done. Python packages, Opentrons environment is created. So let's go to the next step. Let's install the Visual Studio Code, and that can be done using the Visual Studio Code package we downloaded. Let's install. So I would like to add Visual Studio Code to the path as well, and add Open with Code and add Open with Code to the Explore directory, both of them. If you want, you can add it to the desktop as an additional icon. I'm going to uncheck it at the moment. Click Install and let it install for, this should take a few minutes. Now our Visual Studio Code installation is finished. Let's launch it. And let's go back to our requirements for the Visual Studio Code. So now, as you can see over here, we want to do the second step is set up Opentrons Python environment as default in Visual Studio Code. Again, this is an important step in Visual Studio Code to make sure you're able to run the right Python package. So let's go to the Visual Studio Code. Now, I'll just skip this process. I'm not interested in setting anything up at the moment. So what we'll do is just create a new window and let's open a folder for it. On our desktop, let's create a folder name protocols. You can name it whatever you want. And protocol, let's create select folder. So in this case, would you like to trust the authors? Yes. And now right click and create a new file. Let's call it as demo.py. So the good thing about Visual Code is it requires you to, it automatically detects what programming language you're going to use. So .py is Python. And now you can see at the bottom, do you want to install the recommended Python extension? So yes, we definitely want to install this. And let me quickly go back to the presentation. Here in the extensions, we want to install a few extensions, which are Python, Pylance, JSON, Prettier, and Rainbow. So the purpose why we would like to install Python is it will be able to find out what Python versions are available in our operating system. So after clicking the installation, this should take a few minutes. Right after the installation, this window pops up. Right now, I'm just going to skip this. Now you can see something has changed at the bottom. There are a lot of things which are newly available after installing the Python extension. And this is where you can see 3.12.7, which is the base Conda. So this is the default Python version from Anaconda. What we are going to do is click on this and change it to the environment which we created for 3.10.16, which is Opentrons. After clicking this, you can see at the bottom of the screen again, 3.10.16 is visible again. And this is what we would like to keep it as our default environment. Now, what I'm going to do is click on Terminal, New Terminal. So selected Conda environment was successfully activated, even though Opentrons indicator may not be present in the terminal prompt. So right now, we are still using the Opentrons environment. This is critical just to make sure we are using the right environment. The first thing we are going to do is going to type Python --version, click on enter. So if this would have been a different version, Python 3.12.7 would have prompted over here, but we are in the correct version. We are in Python 3.10.16. That's what we want. If by chance you're in a wrong version, my recommendation is you close your terminal, that is click on delete, close your VS Studio Code and just open the new VS Studio Code again. Sorry, I meant Visual Studio Code or VS Code. Okay, let's open the folder again. I recommend working in a folder. It makes life much easier. So let's open the protocols folder. And this has the demo file. I'm going back to the terminal, click New Terminal. I'm seeing that the Opentrons version is being used for VS Studio, Visual Studio Code. Sorry. I'm going to confirm once again, we're using the right Python version. So Python. Okay, that's the wrong one. So we would like to have the right Python shell. And now it says, I'm just going to delete the top one because this was the wrong Python version. And let's type Python version again. Again, this is the wrong one. So let's launch this and let's type Opentrons. Sorry, let's type Python version again. Okay, this is correct version 3.10.16. Again, as I said, this is a critical step. We want to make sure we are in the right Python version. And now we're going to type pip install Opentrons. So basically what this will do is install the Opentrons Python package. This should be pretty quick if you're using the same environment. My recommendation is now keeping the Opentrons environment strictly limited to use Opentrons protocols. The reason being, there is a lot of cross-compatibility issues, and that may crash your simulator once again. So let's type Opentrons. This has been installed. Let's type Opentrons underscore simulate and hit enter. If the package is successfully installed, we will be able to see everything, as in see the command, how the command can be executed. Good. So the first thing is done, which is the Python Opentrons Python API is installed. Now what we would like to do is add a couple of more features. Basically, we'll go back to the presentation. In the extensions, we install Python. Now we would like to install pylance as well. So the pylance library allows you to look into different Python packages and their interior functions. So we're going to install a few extensions which are pylance, JSON, Pretty Printer. The only reason we would like to install JSON is you might be working with different Labware, custom Labware, so it might be a good idea to have JSON Pretty Printer installed. And Rainbow CSV. The Rainbow CSV allows you to see different columns with different colors in the VS Code environment itself. So let's get these three packages installed: pylance, JSON Pretty Printer, and Rainbow CSV. We are going back to VS Code, and you can see in the extension tab. So on the left-hand side, the Explorer is where you can see the code. Search is you can search through your code base. Source control is for your GitHub. Run and debug is for debugging your protocols. And then extensions, we're going to install pylance, which was automatically installed. Okay, perfect. So after installing Python, pylance was automatically installed. Then let's install JSON Pretty Printer. And again, this is Trust Publisher and install. This install immediately, and then let's install Rainbow CSV. Okay, I'm going to trust this publisher and get the Rainbow CSV installed. Perfect. So everything is pretty much installed now. And we have our Visual Studio Code. I'm going to just close this extension tab. We have the protocol. I'm going to go back to the Explorer tab. And in the demo protocol, let's actually try one of the demo protocol. So to find the demo code, what we are going to do is go to the Opentrons documentation page and copy the code. And let's use VS Code further to look up different functions in Python API. And also let's simulate your first protocol. I'm going to minimize the VS Code. Let's go to Opentrons Python documentation. So it's called as Opentrons API. And this is open in the new tab. So this is for the OT1 index. So I'm looking at the wrong information. The first thing I would do is just click on the Opentrons logo over here, which is not redirecting anywhere. So I'm just going to erase this. Click on docs.opentrons.com. So docs.opentrons.com/v2 is the version we would like to take a look at. And I'm going to scroll down, copy the Python protocol. So for the flex, Well, let's copy this protocol. Copy and paste it into our VS Code. So the good thing about VS Code is you'll be able to see the code in different colors. Again, you can change the theme depending on what you like. And I'm just going to save it for a moment. It automatically indents your code. For example, like if I'm going to type left underscore pipette dot something. So it is automatically indenting your code, and we'll be taking a look at the pylons feature shortly. So now what I did is I saved the code. If there is any change made, for example, hello, which is not really recommended. So you see a white logo over here, white icon. That means the code is unsaved. So after, what we can do is like file, and save. So that saves the code, or you can use Control S, Command S, depending on your operating system. I'm just going to comment this out. In VS Code, you can comment using Control and / and save the code. Okay, so we have the protocol right in the VS Code environment. Now let's simulate this protocol, like what it is exactly doing. Now in the terminal, I'm going to type opentrons underscore simulate space the protocol name. So here our protocol is called as demo.py. And there you go. So you're able to simulate the code, picking up the tip from XYZ location, and then aspirating from some location, dispensing. That's exactly what the code is doing. So for example, if you look at the command, this is picking up the tip, aspirating, then 100 microliters, and then plate A1, then dispense 100 and plate B2. So it seems like everything is correct. But for example, let's introduce an error over here. I'm going to type clear such that we can see a clear screen over here. And let's try to dispense 10,000 microliter. So I'm going to click up arrow twice, and we can run the same command. Now we can see that protocol command failed error, line 32. So let's go back to line number 32. Okay, in line number 32, it says that invalid dispense volume error. Cannot dispense 10,000 microliter when only 100 microliter has been aspirated. There you go. So now we are able to spot out on line 32, we just need to correct this code. And sometimes what happens is you are going to incorrectly type something. So for example, over here, VS Code also quickly shows you the error. But for instance, we corrected it, and let's run the Opentrons simulate demo.py. And it gives you unterminated string detected at line number 32. So now you can go back in your code base, line number 32, something is going wrong. Okay, let's correct this. That's pretty much it. So now we have successfully installed the emulator, simulator, Opentron simulator. You can simulate, view your protocols. One last thing which I wanted to show you is, since we installed the pylons, we can actually look up what are the other functions associated with the pipette. So left pipette, and if I click dot, left pipette is an object basically for left one channel 1000 microliter pipette. It has the following associated commands. So you can do a blowout. You can actually configure it for volume, which is not really valid for 1000 microliter. You can actually check what is the current volume available. And for example, if I would like to see what this is, what we can do is type print and then close the command, and let's simulate it again. So with the current volume, we will be able to see, okay, so all the print commands are printed first in the beginning. If you want to print this after all the details have been printed, you'll have to type protocol.comment, and let's rerun the protocol. Okay, so protocol.comment requires this to be string. I'm just going to type string and rerun the protocol. So now in this version, we can see it's 0. So the current volume available is 0. Now, what are the other functions which are available? So we can take a look at how many channels this pipette has. So let's just run this protocol. So this is a single channel pipette. And that's correct because Flex one channel, 1000 microliter pipette. And then there are other functions which are associated with the object that is left pipette. So Pylance allows you to understand what are the associated functions. Instead of using dir and your object, you can actually directly find out what are the associated functions to the particular object. Now, the last step which I wanted to show you is if you have a custom Labware in the same folder, what you'll have to do is type opentrons _ simulate demo.py. So let's go to Opentrons website, which is protocol library. They may have some link over here, tools, protocol library. So let's download one of the protocol from their protocol library. Okay, let's just see, view all protocols. Now, for example, we are going to work with, let's see if there is any different protocol. So this is community verified. Let's look at what this protocol is. And it uses pretty much all the standard Labware. So I'm looking for a protocol which doesn't use the standard Labware. Let's see if there is any other. Okay, so I don't have any specific Labware which might be helpful at the moment. Let me quickly take a look. Okay, I was able to find a protocol which is basically blood punch distribution. And now we would like to download this protocol. Let's open it and double click it. So this has blood protocol and there is custom Labware. Let's copy this and put it into our download folder, for instance. Let's call this, let's create a new folder, custom protocol. And I'm going to add both the things, blood and custom Labware into the custom protocol. Let's go back to VS Code. Like I said, the best practice is to open a folder, which eases a lot of things. So I'm going to go to my downloads folder, custom protocol, and let's just select this folder. What we would like, okay, I would like to trust the authors of this protocol, and I would like to open the Opentrons protocol. So if I'm going to test this one, so now you can see again, selected Conda environment was successfully activated, even though base may not be present in the terminal. Actually, you can see at the bottom, I'm still using 3.12. I would like to keep 3.10 as my default environment. Let's just confirm which environment it is launching. It is saying reactivating terminals. Let's give it a second. Seems like it has activated, but let's verify if this is the correct no. So I'm going to click on plus. And now it is saying selected Conda environment was successfully activated. Just to verify, I'm going to type Python version. Again, there is a problem. So this is a very common problem where you might end up restarting your environment. So let's see if this is the right environment. Let's type python/version. Okay. If this is a common problem, another option I would recommend doing is type conda activate Opentrons. That's our environment. And now we are into the right environment. So let's type Python version. Okay, this is not working. I'm just going to close this terminal, start a new terminal again. Let's see once again. If not, and let's see if Opentron Simulate is actually running on this one. Okay, this is again an example. We are not in the right terminal, right environment, because this is showing still that 3.12 is opening. So I'm just going to close this. Let's go back to VS Code. This is opening, and let's see what Python version it is going to activate. Okay, this is probably in the right one. Let's take a look. Python -- version 3.12. It's reactivating the terminal. I am not sure if it is doing the right way. Okay, let's try Python version. Nope, not yet. Kill terminal, and let's see if you are able to activate the right one. Okay, now finally we are in the right terminal. Now I'm going to type opentrons_simulate space blood protocol.py. We can see that there is a custom Labware which will result in error file not found, Labware not found. To find out the custom Labware, what you can do is like opentrons_simulate. The protocol is right over here. And then what you can do is drag and drop the folder. So this contains all the custom Labware used, and I'm just going to hit enter. And it wasn't able to find it because we forgot to add dash /. Okay. Okay, now I know what's happening. Let me clear this up. So the command is opentrons_simulate. The protocol name is blood.py, and then type -l. And then we will drag and drop the custom Labware folder, which is L is for where the Labware is located. So that's an argument. And now I think it is simulating. So there you go. The protocol can be simulated, and that's how you basically use the Opentron Simulate to debug your protocols, and how you can use custom Labware in your protocols. Again, just to verify what we have learned today. So we are going to go back to the presentation. This contains all the command list, which is pip install opentrons. That will install the opentrons package in the VS Code. Then opentrons_simulate protocol_name is where you will find simulating the protocol. And then if you're simulating the protocol with the custom Labware in the same directory, you don't have to give the -l argument. All you have to do is just work with protocol name.py. And if your Labware is in a different directory, then you'll have to use the custom Labware path or the L argument. That's pretty much it, guys. Thank you for watching.